A transpose A is equals to A11 square, A12 square, A13 square, and so on, A33 square. Sum of squares of all elements. So now they have given that. What else they have given? Aij belongs to -1, 0, 1, and then like here 1 less than or equals I comma j less than or equals. So now the trace value should be equals to 6. So I would say after writing this equation, our matrices is done. From here, we need to do the problem or we need to solve the problem using permutation and combination concept. Clear? So like, let's say, imagine a situation, I'm using 9 ones. If I use 9 ones in the matrix, if I do squares and adding the all the elements, sum of squares of the elements, in such matrix, we will get as 9. 1 square, and so on going till 1 square, it will be 9 there. Clear? So next, if I am removing 1 and I am replacing the 1 with 0, 8 ones I am using. Plus 1 or minus 1 doesn't matter since I am doing square here. Clear? 8 ones and 0 if I use there, I will be having 8. 7 ones, I will be having 7. So that means only one chance I can use 6 ones. The ones can be plus ones or minus ones. There is no problem in that because we are doing squaring. After that only we are adding. Clear? So now 6 of these elements should be either plus 1 or minus 1. Remaining 3 elements should be equals to zeros. Am I clear in this? So like here. Now 3 elements should be zeros and 6 elements can be 1 or minus 1. I hope everybody understood why I am including minus 1 as well. Right? The square only we are doing, no? Square you do, the minus 1 becomes plus 1. Now like number of such matrices, I am using combinations and I am using permutations. First of all, out of 9 boxes, in 3 boxes, I need to fill with zeros. Clear? So that what I need to do is I need to pick the 3 boxes where I want to fill zeros. That will be 93 ways of selecting the boxes. After selecting the boxes, let's say I selected A11, A12, A13 to what you say arrange these 3 elements with 3 zeros. I can do in one way. 3 factorial divided by 3 factorial because all 3 are identical. After that, once I've done with my filling zeros, right? Now the remaining 6 boxes has how many chances? Each box have 2 chances because it can be plus 1 or minus 1. Am I clear in this? So like 9C3 into 1 into this 1 is for arranging the 3 zeros in 3 boxes, and then 2 into 2 into 2, right? 6 times I'm multiplying. To any doubt in this? Anybody? So now my final answer here is 9C3 into 2 power 6. Clear? Any doubt anybody? You calculate this one. Next, like similar problem you have in the book, I would ask you to solve now and then tell me the answer. That is problem number 3 of page 48. Copy this problem, including the question as well. Including the question as well. It is not there in our book. I have checked it. Before it used to be there. After question, you please copy the solution, then go to the page number 48, problem number 3. Same concept. Instead of -1, 0 and 1, they have given 0, 1, 2. What they need is sum of the diagonal elements in M transpose M should be 5. Am I clear? Can I scroll this one up, my dear students? Any doubts, my dear online students?
No, sir. Sir, can you explain this one more time, sir?
You want me to explain one more time?
Yes, sir.
Wait a moment. So, like from property number 6 of transpose of a matrix, I wrote here
Okay, sir.
trace of A transpose A is equals to sum of squares of elements.
Okay, sir.
So, according to the problem, it should be equals to 6. Now, I
Okay.
need 6 now. I tried using all 9 ones, not working, 8 ones, not working, 7 ones, not working. Then 6 ones, 3 zeros. The ones can be +1 or -1. There is no problem in using -1 as well. So I concluded we need to fill the 9 elements using 3 zeros and 6 ones or -1s. Right? So now I am writing directly using permutation and combination. Number of such matrices is 9C3 into 1. 9C3 into 1 is, first of all, I am selecting the 3 elements where I am filling those elements with 0. 3 boxes where I am filling those 3 boxes with 0, that is 9C3 into 1. 9 are available. Selecting 3 will be 9C3 and then filling them is into 1. 3 factorial by 3 factorial. Now the remaining 6 boxes, we have 2 chances each because each box has either +1 or -1 as a chance. Clear? Now 9C3 into 2 power 6. The given problem is a numerical answer type. So you should calculate and write the type the integer in the exam. Am I clear? So you guys solved that next problem. Finished it. Then solve something else. So if you don't have the book, so sign it in. Doing. Why you didn't got? Your friend saying we didn't got. So what is given? How many 3 by 3 matrices M with entries 0, 1, 2 are there, for which the sum of the diagonal elements, that is trace of M transpose M should be equals to 5. Trace of M transpose M will be equals to sum of squares of all elements in M is equals to 5. So like again think guys, 9 zeros. Option 4 maybe that I don't. Option I didn't remember. You can check from backside. 9 zeros or 9 ones or 9 twos, like that you use. If we use 9 ones, we are having 9 there. So we need 5. If we need 5, what we can do? 5 ones, 4 zeros. That is one case. Clear? So now instead of 5 ones, what else I can do? I can also use single one and then no single 2. single 2 and then single 1. Then remaining all should be zeros. Two cases. Understood? Now do case 1. Four zeros and 5 ones. In this case, number of such matrices. You can write this one as 9c5 or 9c4, right? Or you can also say this is 9 factorial by 4 factorial into 5 factorial. 9c4 means out of 9 boxes you are selecting any 4 and you are dropping zeros in the 4 boxes. Clear? Remaining 5 boxes will be automatically filled by ones in one way. Clear? So the answer in this is 9 factorial by 4 factorial into 5 factorial. So how much I get in this case? I think like I should simplify 9, 8, 7, 6 divided by 24 I have. This is 63 into 2, 126 is case 1. In case 2, 1, 1, 1, 2 and 7 zeros. Huh? 3 ones, no. Square we are doing, no. 2 square is 4. Then 1. 5 only, no. 3 ones won't come. Number of such matrices. So again, permutation you go 9 factorial by 7 factorial. 9 factorial by 7 factorial is 72. Y into 2 factorial. 9c7. See dear. First of all, let's say you are selecting. Okay, if you write in that way, if you are selecting 7 boxes out of 9, that is 9c7. Zeros you dropped. Remaining 2 boxes you are filling with 2 distinct elements into 2 factorial. Same only you will get. Here you won't get 2 factorial. If you write 9c7, there you will get 9c7 into 2 factorial. Simplify 9 factorial, 7 factorial, 2 factorial into 2 factorial. 2 factorial we are multiplying because there is 0 and 1, two distinct elements we are like arranging in 2 boxes. 2 elements, 2 boxes, 2 factorial. Clear? It can be 1, 2 or it can be 2, 1. Any other doubts? So copy this. Then you please put one subheading, symmetric matrix. You would have seen symmetric matrix in NCERT. What we extra we learn in this is like the properties what we use in JE. Symmetric and skew symmetric matrices are very close to even and odd functions. Symmetric matrix we can compare with even function. Skew symmetric matrix we can compare with odd functions. As we learned in functions, there are some functions which are neither even nor odd. So here also there are some matrices which are neither symmetric nor skew symmetric. One by one we will see again types of matrices only we are going. Everybody copied this? So this is in types of matrices, symmetric matrix. So this one says, definition says a square matrix A of order n is said to be symmetric if A transpose is equals to A. After interchanging rows and columns, if we are getting same matrix, that is known as symmetric matrix. Clear? I think I forgot to mention earlier, if you are doing transpose of identity matrix or if you are doing transpose of null matrix, you will get identity and null as well. Clear? So now some example for symmetric matrix. Let us take order 2 symmetric matrix initially. Matrix should be square, then only we have symmetric or skew symmetric. What happens, guys? Exactly, can you tell me why we are imposing the restriction? It should be a What happens if it is a rectangular matrix, non-square matrix? When we are interchanging rows and columns, the order of matrix will be different. When order is different, we cannot say the matrices are equal to each other. We learned in equality of matrices, the matrix A will be equals to the matrix B only if they are of same order. And then every element of A is equals to every element of B. Clear? So now if you do transpose of this matrix, what you will get? You will get 1, 2, 2 and 3, which is same as A. Clear? Understood? Right, maybe in general, let me write how the second order and third order symmetric matrices looks like. In example only, I am giving. So let us say matrix M we are taking. This matrix M, if it is a symmetric, we should have A, B, B and C here. Clear? You take in general and then you do A transpose, equate A transpose with A. In that case, you will get A12 should be equals to A21. The third one, if we are seeing for order 3, N is equals to, you can take A, B, C, and then this is B, C, D, E, E and this is in general the order 3 symmetric matrix. Clear? Understood? This is how it looks like, the symmetric matrix of order 3. So now below this, like I'm not going in detail of properties and all. What I'm asking is like two questions I'll ask you. I ask similar kind of questions in upper triangle and lower triangle as well. Let's say I need to form a symmetric matrix of order n. So like how many distinct elements you think we can use? Maximum situation I'm talking. If you want order, what order I have mentioned? Order n you take, not 3. So let me write here, this is note point for symmetric matrix. In this note point 1, the maximum number of distinct elements are required to form a symmetric matrix of order n. How many you guys think? N into, yes, perfect. N into n plus 1 by 2. How actually they did? If somebody asks me, I say like, first of all, you consider in order n matrix. all elements of row 1 has no restriction. You can use n distinct elements in row 1. Clear? You take order 2 matrix. This is A and this is B. 2 are distinct. Order 3 you take this is A, this is B and this is C. 3 we can use maximum distinct elements. Clear? Now that means for order n it will be n elements I can use in row 1. In row 2 guys, this element if you see it is copy of this element. Am I clear? Now here also this element is copy of this element. So like now how many I use above? I should use one less than the above. So it is n plus n minus 1. In second row I can use n minus 1 distinct elements. In third row I can use n minus 2 distinct elements and so on. The last row I can use only one distinct element. Doesn't matter whatever the order is. Only one element is distinct, remaining are copy from the above elements. Clear? So now these are all sum of n natural numbers n into n plus 1 by 2. These many maximum number of elements, distinct elements we can use. Clear? So if somebody asks the maximum number of non-zero elements, it is not that important. We can use is n square. Everything can be non-zero. Clear? No restrictions, so that I'll leave that one aside. Next is skew symmetric matrix. You can write the definition similar to symmetric. Only change it will be having is A transpose is equals to minus A. Skew symmetric matrix is similar to odd function. Symmetric matrix is similar to even function. A square matrix A of order n is skew symmetric if A transpose is equals to minus A. Examples of skew symmetric matrix. Zero, A minus A and 0. One thing you can observe in a skew symmetric matrix, the principal diagonal elements will be always 0. In general, example number 1 is how your skew symmetric matrix of order 2 looks. And then the example number 2 is like in general how the skew symmetric matrix of order 3 looks like. Clear? Now, doubt. You want proof, like then we can do that here. Let us say if A is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33 is skew symmetric. Then if it is a skew symmetric, then we are solving. We'll show that. A11 is equals A22 is equals A33 is equals 0. As a small proof we will do. The definition of skew symmetric says A transpose will be equals to minus A. A transpose is equals to minus A. I am doing transpose and I am writing that one on left hand side. So we have A11, A21, A31. Column 1 I have taken, I wrote as row 1. Column 2 I have taken, I am writing as row 2. Now column 3 I am writing as row 3. This should be equals to minus 1 into A11, A12, A13, A21, A22, A23, A31, A32, A33. Clear? So now equality of matrices, right? First row, first column element should be equals to first row, first column. So like A11 should be equals to minus 1 into A11. Please don't forget this minus 1. Scalar multiplication of matrices, you should multiply to everything. Now like second row, second column element should be equals to second row, second column element. Third row, third column element should be equals to third row, third column. So like change this side. You will get 2 times of A11 is 0. From there A11 is 0. A22 is 0. A33 is 0. Clear? Understood. This is why. Now think and tell me. Same question. Note point we wrote no earlier. The maximum number of distinct elements required to form a skew symmetric matrix of order n. The maximum number of distinct elements are required to form a skew symmetric matrix of order n. N into by 2 will be there, I guess. Any doubt? You want explanation in that case? N into n minus 1 by 2 is what my argument. For that, you please observe here. In second order, we are just filling the elements in upper triangle. Diagonal is 0, lower triangle is image of upper triangle, minus 1. Same thing in order 3. A, B, C is upper triangle. Lower triangle is minus A, minus B, minus C, automatically filled. Diagonal is 0. Correct? No, like A and minus A, like what I am saying is, automatically if it is A, it should be minus A. No, I'm not saying in that way. Like if it is A, then it should be minus A. If it is B, then it should be minus B. Clear? Once you fill A there, it will be minus A by default. Don't consider that one as a different element. That's what I mean. Clear? Understood? No. By 2 only we will get. So add that one as well. After adding it, we see the properties one by one. See, A and minus A is, listen to me, A and minus A, B and minus B, C and minus B are different elements, I agree. Once you fill A, B, C in upper triangle, minus A, minus B, minus C will be filled automatically. Clear? If you need skew symmetric matrix, row 1, you can use n minus 1 distinct elements. First element, first row, first column element should be 0. In distinct, you add this one also, non-zero. 0 we are not counting. N minus 2, n minus 3, and so on. In last row, 0 required. N minus 1 into n by 2 is what you will get. So guys, in properties, who will be telling how many skew symmetric matrix of order 1 are possible and what are they? How many skew symmetric matrices of order 1 are possible and what are they? Huh? What are they? Perfect. Did I say this one
Zero,
earlier?
null matrix.
I think I told in one class, right? Yes, null matrix is the only skew symmetric matrix of order 1. Clear? So the same null matrix we will also say as symmetric and skew symmetric both. Write this one, first property. Null matrix is the only skew symmetric matrix. If we are talking about order 1, null matrix is the only skew symmetric matrix. Second one, null matrix is the only matrix which is both symmetric and skew symmetric. In functions, we have given null function is the only function. Okay. So next, third one. Any square matrix A of order n can be expressed as the sum of symmetric and skew symmetric matrix or matrices. We can write a matrix A is equals to A plus A transpose by 2, A minus A transpose by 2. So like this is symmetric part. Next is skew symmetric part. We use this property for neither skew nor symmetric matrices, right? Fourth one. The principal diagonal elements of a skew symmetric matrix are equals to 0. If A is symmetric, then A power n is also symmetric. If A is skew symmetric, then A power n can be two situations: symmetric whenever n is even, skew symmetric whenever n is odd. It's very hot inside. No AC here today. This one is not working. Okay, no problem. If A and B are symmetric matrices, then AB plus BA is symmetric and AB minus BA is skew symmetric. So these are all the properties. Let us solve some problems on this. We have problems asked on the properties of symmetric and skew symmetric in both mains and advanced. Open step 2 PYQs of mains. In PYQs of mains, problem 42, statements are given. We need to verify which of the given statement is true. Using the properties of symmetric matrix and using the properties of transpose of a matrix, we need to solve it. 42 is what I said. So let me copy that one. So this is the problem everybody copied, I guess, the properties. This is the problem step 2, problem 42. It is a problem, right? Before seeing something like this in mains, I have seen a problem in advance. You can also check similar kind of problem first they asked in advance. This was like inspired from advance only. You can see in section G, I'll also show later. So this problem, what we need is we need to know the definition of symmetric, we need to know the definition of skew symmetric, and we need to know the properties of transpose well. If you know these three things, you can solve this problem. What they have given, let us write the given details. In the problem, it is mentioned that a, B, C are three matrices such that A is symmetric, B and C are skew symmetric. So from the statement we are writing A transpose is A, B transpose is minus B, C transpose is minus C, using the definition of symmetric and skew symmetric matrices. Clear? So now next, consider the statements. Statement number 1. Let us say in statement number 1, I am calling the given big matrix as M. So matrix M is equals to A power 13, B power 26 minus B power 26, A power 13. Give me a moment. I think I missed this property in transpose. Did I give this? Transpose of AB? No, I didn't give. Add here. When you have AB whole transpose is equals to B transpose into A transpose. Let us do the transpose. If I am getting M transpose is equals to M, it is a symmetric matrix or else not. So A power 13, B power 26 minus B power 26, A power 13 whole transpose. Transpose is distributive over addition and subtraction. So now let us write this will be equals to A power 13, B power 26 whole transpose minus B power 26, A power 13 whole transpose. Now, if I have two matrices in multiplication, when I am applying the transpose, order of a matrix we need to interchange. This is B power 26 whole transpose into A power 13 whole transpose minus A power 13 whole transpose into B power 26 whole transpose. Right? Transpose and power n can be interchanged. So we are doing that. This is B transpose whole power 26 into A transpose whole power 13 minus A transpose whole power 13 into B transpose whole power 26. From equation 1, A is symmetric, B is skew symmetric. Using that, minus B power 26 A power 13 minus A power 13 into minus B power 26. Right? So since minus B power some even number is there, this becomes B power 26 A power 13 minus A power 13 B power 26. Let us take minus 1 common. This will be A power 13 B power 26 minus B power 26 A power 13. So I got here M transpose is equals to minus 1. M transpose is equals to minus M implies that M is skew symmetric. So statement 1 is false. So one more statement is there. So let us solve that statement as well. In second statement S2, let us call the given matrix as n. N is equals to A power 26, C power 13 minus C power 13, A power 26. Right? Now taking transpose, N transpose is equals to A power 26, C power 13 minus C power 13, A power 26 whole transpose. Now transpose is distributive or subtraction. So I am doing that. So interchanging them, it is C power 13 whole transpose, A power 26 whole transpose minus A power 26 whole transpose, C power 13 whole transpose. Now transpose and power let us interchange. C power C transpose whole power 13, A transpose whole power 26, A transpose whole power 26, C transpose whole power 13. C is Q symmetric, A is symmetric. Minus C power 13, A power 26 minus 1 into A power 26 minus C power 13. So like minus 1 power odd integer, it will be minus only. Minus C power 13 A power 26 plus A power 26 C power 13. Now this becomes A power 26 C power 13 minus C power 13 A power 26. Here I got n transpose is exactly equals to n. Therefore the given matrix is symmetric. So statement 1 is false but statement 2 is true. Any doubt in this, anybody? Any doubt? Anybody? So like I'm using two main properties of transpose. AB whole transpose is B transpose into A transpose. I missed it. You please add it there. Let's say you have n matrices in multiplication A1, A2, A3, An whole power transpose. That will be An transpose into An minus 1 transpose and so on. A2 transpose into A1 transpose. Order will be reversed when you are taking transpose inside. Clear? So now in the same way they asked problem earlier than means in advance. That is problem number 8 of page 49. More than one correct type. Problem 8, page 49. Let us mark attendance. You guys please try page 49, problem 8. So like anybody didn't punch their offline students? Call that boy. Did you punch there? Lohit? Lohit is not there. Yes, Gautaman. Why you didn't punch there? Srinikesh? Done. Finish that problem. Copying anybody? This one? Anybody writing this problem? Writing. Right. So what is the status for problem number 8 of page 49? Sorry? Your friend is having, no? You can share with your friend. He's sitting next to you, dear. Sai Nitin. Page 49, problem 8. Finished? Didn't seen yet? Venkatesha? Srinivasa. I didn't know who is Srinivasa, who is Venkatesha. Tell me you did. You are Srinivas. You are elder or younger? Elder. He is your brother, younger brother. Srinivas. He is Venkatesh. Okay. Tell me. Somebody said they are writing, copied this problem. This is the problem I asked you to do. There are more problems like this. I think problem 40 is also similar. I think try 40 as well if you finished it. Forty as well, please. Don't go home and relax. Eighth one, anybody has doubt? 40. 40 is step 2 problem only. If you have book, try once. I think eighth one is more than one, correct? X and Y are B2 arbitrary non-zero skew symmetric matrices. B is what? Okay, which of the following are symmetric? I'm telling B is not symmetric. Oh, sorry, B is symmetric. This is not skew symmetric. Discarding this. Even powers are there. So D can be skew symmetric. Now in between A and C, I should look again. C is symmetric. Then somebody saying symmetric, somebody saying skew symmetric. Keep your phone in silent mode. I'm still in class.
Sir,
You want
C
me to
is
solve?
giving us skew symmetric, sir.
C is skew symmetric is what your friends are saying. What do you get there? Z transpose whole cube. Z transpose whole cube, na, that is Z cube. X transpose power 4, that is X power 4. Minus X power 4 Z cube. Skew symmetric only, dear. So these two are your correct. A I didn't check. I think A. Then C and D are your answers. So what about 40? Option 3. Then which of the following is not true? What are A and B? A is symmetric, B is skew symmetric. Then minus B minus A, not having. That is neither symmetric nor skew symmetric. Quiet, please. Please be quiet. There is a problem in page number 32, problem number 43. Mark that one as homework. Try at home. 43 of page 32. Problem 43 and 40. Then the remaining I will teach few. Do you guys learned orthogonal matrices by any chance in school? Orthogonal matrix? No, that one we should see. Orthogonal, and then if we have some complex numbers inside the matrix, that kind of matrix and all we need to see. I think it's 8:30. If no doubts, online guys can leave. Offline guys, I think
Sir.
I marked attendance for
Sir.
everybody. You guys also can leave.
Sir.
Some doubt? Who is speaking? May I know your good name?
Hariharan, sir.
Hariharan, tell me.
Sir, take the
Where is
42.
your friend Ray? Muthu
Sir.
Selvam is not attending classes.
Sir, he tell me yesterday I have so much homework, so it's tough to
So
continue.
much homework,
It's tough to continue upcoming classes, sir.
Okay.
Take the 42 sum, sir. 42.
Wait a moment. Dear offline students, please don't make noise. I was not able to hear what online student is asking. Please pack your bags and leave quietly. Don't make noise. Yes, Hariharan, tell me.
Sir, take the 42 sum, sir. You talked me before.
40?
2. 42.
This one.
here. Sir,
What is your
improving the,
doubt in this?
sir, improving the first sentence, the fifth step, why we add that the minus b, sir? I did not understand the fourth and fifth steps.
I didn't. Please wait here, Hariharan. You can go home. I am saying don't make noise. My laptop speakers are not good. I was not able to listen what your friend is saying. Thank you. Thank you. Thank you. Thank you. Thank you. Please wait, dear Hariharan. I'll solve your doubt.
Okay, okay, sir.
Huh? No, I cannot hear. You guys are making noise. No, I liked your school uniform. I want to see everybody in the classroom wearing this uniform.
In our school, stay alone. Everyone. Yes, sir.
So you two guys will also wear.
Yes, sir.
Thank you. Thank you. Thank you.
Thank you, sir.
Thank you. Yes, dear Hariharan, now tell me.
Sir, improving the S1 sentence, the
Huh?
fifth step collapsed, sir. The
Fifth
fifth
step.
step, 1, 2, 3, 4, 5. The fifth step, why we add the minus p power 26?
This
Sir?
one.
Why? No. Scroll down, sir. Scroll down.
Okay,
The
like this is step 1, step 2,
yes,
step 3, 4,
4, 5.
5.
Why we add the minus?
Because B is skew symmetric.
Okay, sir.
B transpose is minus B.
Like A transpose also the minus A, than, sir.
A transpose is symmetric.
Okay, sir.
Hmm.
Okay, sir. Clear, sir.
Then you can go home.
So the diagonal A1 is equal to minus B.
Science level. Any other doubts, online students? If no
No, sir.
doubts, you guys can leave. We'll see again in next class. I would like to say thank you for attending my class.
Thank you, sir.
Thank you, sir.
Thank you. Which problem, dear? You see there?